Okay, guys. So I know it's been rough. It's been a couple of weeks that have been really, really hard. I am super, super glad that we are starting to work again because, uh, you know, we've been dealing with a lot of stuff, but at least going back into the routine will help us all a little bit. At least I hope so. Um, so yeah, this is going to be a quick recap on what we have already seen. I'm doing this on my own time so that you guys have at least have a video that tells you basically what we've worked on, and you can go back to this video because this one will be the basics on what we'll be doing in the next couple of weeks. Literally, the next couple of weeks we will be looking into cinematics, and then we have to move on into dynamics and statics. But before we get to that, let's get our bases uh, completely covered again. So let me move things around. I'm not recording my webcam because I think you guys don't need to be looking at my face right now. What you need to be looking at is my cursor right here. So let's see. Let me try. Let me see if this thing works. There we go. Yeah, works. Okay. So so let's do a quick recap. Let's see, recap on what we have already seen. So let's start with something called speed. Oh shit, sorry. Let's see. I'm kind of new to this, so my handwriting will be kind of bad at the beginning. I hope it'll get better uh, by the next couple of weeks. So let's look at the first distinction we're going to be making. So let's see the distinction between speed and velocity. Oh, that's horrible. I apologize, but that's what we have right now. So I'm doing my best here. So speed, okay, and velocity. Both of these quantities express more or less the same thing. They express a change. Remember, delta indicates change in position, let's call it x, over a certain change in time. Both of these quantities, speed and velocity, will be giving us this information, a change in position over a change in time. The main difference between these two is that speed is a scalar quantity, so let's put scalar here, and velocity is a vectorial quantity. What does that mean? Well, basically, it means that speed is basically a number, okay, that it's indicating how much my distance is changing over a certain interval of time, how much my position is changing over an interval of time, and velocity is telling me the exact same thing, how much my displacement is changing over an interval of time, but it's also indicating me a certain direction. So let's put it here, direction. Right? So that's the main difference between speed and velocity. Both are quantities that are indicating a change in displacement, a change in position over time, but velocity will be giving me a little bit more information since it will be giving me the direction. Okay? Uh, when we're talking about one-dimensional movement, so 1D movement, 1D movement, when we are looking at one-dimensional movement, velocity, the sign, is something that is going to be super important for us. Why? Because we first need to specify a plane, a reference plane. Okay. So, for example, let's say that we are evaluating how this ball is moving over, I don't know, this surface right here. Whoop. Imagine that this is straight. Wait, I think I can actually draw it straight. So yeah. Oh yeah, there we go. Okay, so imagine that this ball, we're gonna be analyzing the movement of this ball over this surface right here. Uh, when we talk about speed, I'm sorry, velocity, in one-dimensional movement, we need to specify which direction is the positive direction. So this will be a positive x, right? And since we're only moving in one direction, we don't care about anything going in this direction or on the plane, right? We are only working on this direction. So once we specify that positive is going to the right and negative thus is going to the left, we have enough information to evaluate the velocity of this particle here. If the velocity turns out to be positive, it means that we are moving to the right. If velocity has a negative sign, it means that we are going to the left. Pretty simple, right? So when we talk about movement in one dimension, it might be tricky. You guys might fall for the trap that we are not actually using vectors, but that is completely false. We are using vectors because we are giving the velocity vector the direction with the sign, right? So this will give us, here, let me put another color here. The sign will give us the direction. So yeah, there we go, direction. Okay, so for example, let's say, remember that we did a quick, let me see if I can, wait, remember, be patient with me. I'm trying to do, okay, there we go. Okay, so let's close that. Okay, so remember that we did an analysis of a graph of velocity over time. So let's do that here. So let's say that in this direction we have time, and in this direction we have, oh wait, let's call it displacement. So remember that we did stuff like this, that we'd say, okay, so you're going to be moving this much, and then you're going to be staying here this much, and then you're going to be moving back, and then you're going to be moving up again, and so on and so forth. Let's do that here. Let's continue this thing here. Okay, so if we define this to be the positive direction, the positive direction in our movement. So let's look at our ball here. Put it over a surface. So in this first interval, the ball is moving to the right, and thus we would be having a positive velocity. So from this interval to this interval right here, you know what? I'll change color. Let's put blue again. So in this interval from here to here, we have a positive displacement. Therefore, remember that velocity is the change in position, or d, over a change in time. So from here to here, we have a positive velocity. From here to here, since we are not moving, since we don't have any displacement, we have zero velocity. From here all the way down here, so from this point up until this point, we have, let me draw that from here, right, to here. Since we are moving negatively on our slope, on our plane, sorry, we have a negative velocity. Why? Because we are moving actually backwards, correct? We're moving backwards. Okay, so this indicates negative, and this would indicate positive. And finally, from this point up until this point, we have a positive velocity as well, again. Okay, so remember, when we're moving on a plane, one-dimensional movement, even though I'm not giving you the angle of the vector, the angle is implicit in the sign. Okay, so if we have a velocity with a positive sign, that means that we are moving at 0 degrees. It means we are moving to the right. If I give you, here, put this like that. If I give you a velocity with a negative sign, that means we are moving at an angle of 180 degrees. So we are moving to the left. Remember, I'm going to repeat this just one more time because it needs to be super clear. When we have a positive movement, we are moving in the positive direction that we established. At the beginning, we established, write that again. We established that in this direction, so to the right would be positive and to the left would be negative, right? So this is implicit in that. The direction of the movement, the direction of the vector is implicit in the sign. Again, only for one-dimensional movement. Only for one-dimensional movement. Okay, so let me just finish up with this thing right here. Let me add another layer. Add new layer. Let's forget that one right now. Okay, so imagine, picture we have, let me change color. Okay, there we go. So picture we have this type of movement. So this is going to be my displacement versus time graph. Okay. And we have something weird like, let's say this. Okay. This movement indicates that this is my origin, this is my final spot, so I actually moved away from my origin in the positive direction. So let's say, let's look at the example of the ball again. So picture that's the ball. It's going to be moving over this surface. So right at this point, oh wait, I have an idea. Wait, this hadn't occurred to me, but okay, let's try this out. Okay, let's put another color. So at the beginning, the ball is here, right? So at the origin. At this point, the ball has moved to the right in the positive direction of the movement. So right here, let's say the ball is around here, right? It moved to the right, but then at this point, the ball is here, right? Because it moves a little bit to the left. So from here, from T0 to T1, the ball moved to the right. From this point to this point, the ball moved to the left, and finally from this point to this point, the ball moves to the right again, right? So it moves to the right, moves to the left, and then moves to the right again. Okay, so my total displacement, remember, displacement, my total displacement is defined as my final position, final P minus the initial position. Okay, so my final position is here. My initial position is here. So my displacement would be the difference between this point and this point, correct? And therefore my displacement vector will be this one. Oh shit, sorry. Let's draw a straight line. Would be that one right here. This is how much I moved. This is my displacement vector. There we go. The vector. Right? Over a certain interval of time, which would be, let me put this in another color, over this certain interval of time. Right? So, average velocity is defined as my average displacement over an interval of time. So my average velocity of this movement right here would be my total displacement over an interval of time. Remember that we started already working with limits, and what we started doing was reducing this interval of time. So if I analyze my average displacement, but not between the final position and my initial position here and my final position here, but rather, let's say from here 0 to now this new point right here, right there, I would have a new displacement vector starting from here again, but now ending up here. If I keep reducing my interval of time, so this first interval, here let me erase this so that frees up some space. Oh wait, that doesn't work. Okay, I'll figure it out how to erase eventually, I guess. My first interval of time was from here all the way to here. So this is delta t1. Then what I did was to reduce that interval of time from here to here. So that would be delta t2. And I can keep reducing this thing all the way until I find a delta t which is infinitely little. That would give me my instantaneous velocity. So that would be my displacement vector would be right here, like that. Well, not so big. I'll exaggerate it so that you'll see it, but it's actually something really, really super small, like there, over a really small interval of time. That gives me the instantaneous velocity. My instant velocity is defined as my change in displacement over a change in time, but an infinitely small change, and that is called a derivative. A really small increment in x over a really small increment in time. So I'll finish the video here because this shouldn't be news to you. If you have any questions, please feel free to message me. I'll do my next video will be about acceleration, but I'm gonna stop it here so that it doesn't get that boring. Okay, so thank you guys, and I guess that's it. So let's see how to stop this. I have no idea. Patience, everybody. I'm new to this as well. You can exit the video now if you want. Yeah, I don't want to save this. Okay, there we go. So, thank you guys.